Hello, we're Anna, Pearlyn, Lorraine, and Lee. We're going to be talking about trigonometric graphs. We'll start with the three basic graphs: sine, cosine, and tangent. So this graph is the y equals to sine x graph. The graph for sine x has a max and minimum value of -1 and 1 when x is 90 degrees and 270 degrees respectively. Hence, the range of the sine function is -1 and 1. And the height of the waveform from the resting position, called the amplitude, is 1 unit. The sine graph repeats itself for every interval of 360 degrees, and this is called the period. If you look at the graph, we can see that it is positive in the first and second quadrants, negative in third and fourth. This is what we have learned in the course involving ASTC. Same for the y equals to cos x graph, where the range is -1 to 1, amplitude 1 unit, where the period is also 360 degrees. Next, it is the y equals to tan x graph. This is slightly different, where there is no max and minimum value, thus the range is -infinity and infinity. The curve approaches the lines at 90 and 270 degrees, called asymptotes, but does never touch them. The period is 180, where the amplitude is infinity. On to graph transformations. The graph can be transformed in many ways, by varying the period and amplitude. We will be demonstrating various transformations using the y equals to sine x graph. First, we will be varying the vertical stretch or the amplitude of the graph. So, we will be varying the coefficient of fx. So when y equals to 2 sine x, the amplitude becomes twice the original, that is 2. The range will then be -2 and 2. The period does not change. This pattern is the same in the graphs of cosine and tangent functions. Another way to vary vertical transformation is by adding a constant to or subtract a constant from fx. This example will be y equals to sine x plus 2. The range of the graph will be 1 and 3. Hence again, the period does not change. Horizontal transformation. We can do so by varying the period of the graph. We can vary the coefficient of x and fx. An example would be y equals to sine 2x. Notice that the range and amplitude remain the same while the period changes to 180 degrees. The formula for finding the period of the new graph is the original period divided by the coefficient of x. In this case, the period is 360 divided by 2, which is 180 degrees. Another way to vary the horizontal transformation is to add a constant or to subtract a constant from x. Examples would be y equals to sine x plus 30 degrees and y equals to sine x minus 30 degrees. For this kind of transformation, where the transformation is positive, the graph goes backwards. When the transformation is negative, the graph goes forwards. Notice that the range, amplitude, and period of the graphs remain the same as those of the basic graph. For graphs of y equals to minus fx or y equals to f minus x, we follow the ASTC rules. This means that for the sine graph, when fx goes into the negative region, only cosine is positive due to the ASTC rule. Hence, only cosine minus x is equal to cosine x, while sine minus x is equal to minus sine x, and tan minus x is equal to minus tan x. We can sketch the graph by finding 5 critical points, which is when x is 0, 90, 180, 270, and 360 degrees. Let's try by sketching the graph of y equals to minus cos x. Here we're plotting the graph. These trigonometric functions are commonly used for building models that represent and demonstrate processes that repeat in cycles, such as clinical phenomena, which can be found in population studies, waves, growth of living things, as well as electronics. First is the music and sound waves. They share much resemblance with the sine waves. Second example is on electromagnetic waves. And lastly, it is the motion of pendulum. As you can see, all these graphs are similar to our trigonometric graphs. Thank you for your kind attention.